Welcome on this tutorial. In this tutorial, I will discuss about interfacing of DC motor with AVR group of microcontroller. Here, I will discuss how to control movement of a robot which can move with the operation of two DC motors. How the robot can be moved in forward, backward, left, right, etc. Here I will use Atmega 328P microcontroller and I will write the program in C code. I will explain the basic of direction control using DC motor. I will explain algorithms and C code for controlling the movement. Here I will use Microchip Studio and Simul IDE for showing the output. Entering into the discussion, please subscribe and support me. It will encourage me to upload more and more important tutorials. For explanation of direction control in DC motor, I will explain the movement of robot. The robot has a movement with two wheels. Both wheels are connected with DC motor. In this figure, say this is one wheel which is connected with the shaft of one DC motor. This is another wheel which is connected with the shaft of another DC motor. When the shaft of these two DC motor will have a movement in particular direction, these two wheels will move as per that. In this robotic application, the robot is balanced with caster wheel also. This is the caster wheel. So by using this caster wheel and these two wheels connected with two DC motor, the robot can move in any direction. We can control the direction of movement of this robot by using DC motor control action. For forwarding motion, this wheel should move in forward direction. This wheel should move in forward direction. When these both wheels will move in forward direction with a constant speed, then whole robot will move in forward direction. Similarly, when this wheel and this wheel will move just in opposite direction, then the robot will move in backward direction. If we want to move the robot in left direction, this right wheel should move in forward direction and left wheel should move in backward direction. Then the motor will move in left direction. If these two motor will just reverse the direction, the motor will move in right direction. These are another combination of wheels movement for controlling the robot motion. If the right side motor is stop condition and left side motor have forward movement, then this whole robot system will have a movement in right, and opposite of that means if left side motor is stop condition and right side motor have a forward direction, then the robot will have a movement in left direction. These two are normally called soft right movement and soft left movement. There is another type of left movement. Right side motor is in stop condition and left side motor have backward movement. So the whole robot system will have a movement in left direction, and opposite of that ultimately will produce a rightward movement. So by combination of different movement system of these two left and right wheels, the robot movement can be controlled in any direction. Now for direction control, that is for forward direction or backward direction of motor, what will be the polarity of the power supply? Say this is the motor have two terminal, this is one terminal, this is another terminal. This terminal is connected with the positive polarity of the supply and this terminal is connected with the negative polarity of the supply. And then say the motor have a movement in anti-clockwise direction. From this anti-clockwise direction to clockwise direction, we can change the movement of the motor by just reversing the polarity of the supply. Means this is now connected at negative terminal of the battery, and this terminal of the motor is connected now the positive terminal of the battery. Just we need to change the polarity. How this polarity of the supply for a particular motor can be changed, I will explain it a little later. For the operation of DC motor, we need a motor driver IC L293D. Now why this motor driver IC is needed? Maximum current that a port of a particular microcontroller pin can source or sink is around 20 milliampere. This current are too low for motor to run. DC motor with output load requires a current up to 50 milliampere to attain maximum speed. For this additional current, a motor driver is required. The suitable motor driver is L293D, which is mostly used. This is the figure of L293D motor driver IC. Now here I will explain what are the different connections here. 4 output terminals are here, 1Y, 2Y, 3Y and 4Y. So this 4 output terminal can be connected to 4 motors, but in that case all the motors will have a movement in a particular direction. But in our direction control system, motor needs to move in forward direction as well as in reverse direction. So here in this case we have used 2 output terminal to control a single motor. So 1Y and 2Y, these 2 terminal has been used to control a single motor, and 4Y and 3Y, these 2 terminal has been used to control another motor. Terminal number 3 and terminal number 6 is connected to say right side motor, and terminal 4Y and terminal 3Y has been connected to left side motor of the robot. For changing the direction of the motor, sometime 1Y terminal will be given logic 1 signal and 2Y terminal will be given logic 0 signal at the same time. Or if we want to reverse the direction, 1Y will be given 0 signal and 2Y will be given 1 signal. A similar thing will happen for terminal number 4Y and 3Y. Now this logic 0 and logic 1 signal, how that will be controlled? That will be controlled by the signal which will come from the microcontroller. From the microcontroller, 4 output will be connected here to control 2 motors. For one motor, this 1A will be connected to a particular pin of microcontroller. This 2A will be connected with another pin of that microcontroller, and these 2 will be used to control the movement of this motor. Similarly, this 4A terminal will be connected to one terminal of the microcontroller, and this 3A terminal will be connected with another terminal of the microcontroller, and these 2 signal from the microcontroller will be used to control the movement of this side motor. So terminal 2, terminal 7, terminal 15 and terminal 10 will be connected with microcontroller terminal, which will be used to control this motor as well as this motor. In this case, I have connected microcontroller terminal PC0 with this number 10 terminal of this L293D. PC1, that is port C1, is connected with 15, port C2 is connected with terminal number 2, and port C3 is connected with terminal number 7. So this PC0, PC1, PC2 and PC3, these 4 pins from port number C of ATmega 328P have been used to control these 2 motors. This terminal number 1 and terminal number 9 is normally called enable terminals for L293D. This terminal number 1 enable pin is used for this motor, and this terminal number 9 enable pin is used for this motor. Normally for the case of speed control, we need to feed pulse width modulation signal at this terminal number 1 and at this terminal number 9. But in this explanation, only the direction is controlling. So here just we will keep the terminal number 1 and terminal number 9 as logic 1 signal. To provide that logic 1 signal, I have used here port D terminal number 5 and port D terminal number 6 from ATmega 328P, because these 2 terminals have the facility to provide pulse width modulation signal. So when we will use this system for the explanation of speed control of DC motor, then this 2 terminal will be used for providing pulse width modulated signal to terminal number 1 and terminal number 9. But in this explanation, only we will maintain logic 1 signal at terminal number 1 and terminal number 9. Pin number 16 normally given positive power supply. This is the supply for this IC. and at pin number 8 normally plus 12 volt is given. This is used to drive motors. Terminal number 4, 5, 12 and 13, these are grounded. So I have explained all the terminals of L293D. Now how the direction is normally controlled, means for a particular motor, once it will move in forward direction and next time it will move in backward direction. How that can be controlled? For forward direction or backward direction movement, a H-bridge circuit is normally used. This is the figure of H-bridge circuit. Say this is one motor. This terminal and this terminal, these two terminals are say this point and this point. Now this motor is connected with power supply. This is plus B, this is ground. This H-bridge have 4 transistorized switches. This is one switch, this is another switch, this is another switch and this is another switch. And this H-bridge circuit is there into the L293D. Say for a particular moment, terminal number 3 is logic 1 and terminal number 6 is logic 0. At that moment, two switches will be connected. Say this switch will be connected and this switch will be connected. So what will happen? The current will flow from the left direction to the motor to the right direction and ultimately it will reach to the ground. Now when the situation will be just reverse, means this terminal 3 is logic 0 and terminal 6 is logic 1. What will happen? The other two switches, means this switch and this switch will be in short circuit or connected and this switch and this switch will be in open. So what will happen? Current will flow from right side to motor and it will ultimately come out from left side of the motor to the ground. So the current in previous case flowing from left to right and in present case current will flow from right to left. So direction of the motor movement will be just reversed. Now what will be the logic table for controlling the DC motor in different direction? Say the both motor should move in forward direction. For that case, say PC1 should provide logic 1, PC0 should provide logic 0, PC2 should provide logic 1, PC3 should provide logic 0. So logic table is like this. See, this combination provides forward movement of left motor. This combination provides forward movement of right motor. Both motor will move in forward direction, so robot will move in forward direction. If we want the robot should move in backward direction, this will be just opposite of the previous combination and this will also just opposite of previous condition. So the both motor will move in backward direction, the robot will move in backward direction. For left direction, the left motor will have backward movement, right motor will have forward movement, so robot will move in left direction. For right direction, left motor will have forward movement and right motor will have backward movement, so the motor will move in right direction. For soft left movement, right motor will have forward movement and left motor will be in stop condition. For soft right, left motor will have forward movement and right motor will be in stop condition. And if we want to stop the robot, all the terminals will have logic 0 condition. So for forward movement in port C, the value should be 6 in hex. In backward movement, the value should be 9 in hex. In left movement 5, right movement A, soft left 4, soft right 2, and for stop the value is 0 in hex. So as per our requirement, we will provide these hex values to port C. Now in this explanation, I will use Simul IDE and where I will use Arduino board which have Atmega 328P. So I am writing the program for Atmega 328P and the motor will be connected from the Arduino board. For that case, I am explaining the mapping of Atmega 328P and Arduino board. Here I have used 4 terminals from microcontroller pin, that is PC0, PC1, PC2 and PC3. This will provide signal from the microcontroller to the L293D for controlling the movement of two motors. Now where is this connection in Arduino board? These 4 pins are connected with analog pin 0, 1, 2 and 3 of Arduino pin. See these 4 analog pins of Arduino, A0, A1, A2 and A3. These 4 pins are connected to 1A, 2A, 3A and 4A pins of L293D. And for the enable signal of L293D, I have used output compare 0B and output compare 0A, these two terminal, which is nothing but PD5 and PD6 of Atmega 328P. In Arduino board, it is connected with digital pin number 5 and digital pin number 6. See digital pin number 5 and digital pin number 6. This is connected to enable pin number 1 and enable pin number 3. This enable pin for one motor, this is enable pin for another motor. For controlling the direction, what might be the different algorithm? First of all, we need to configure the motor pin. 4 terminals PC0, PC1, PC2 and PC3 from the microcontroller is connected with this L293D. So this PC0, PC1, PC2 and PC3 should be initialized as output pin. Similarly, configure enable pins at output. To enable pin which is connected with PD5 and PD6. So this PD5 and PD6, this will be initialized as output pin, as well as we will provide logic 1 signal at these 2 pins to enable the operation of left motor and right motor. Next, as per our requirement, say we will move the robot in forward direction. Next we will call a delay, means during that delay the robot will move in forward direction. Then we must stop the robot before changing the direction. After stopping, we will move the robot in backward direction. If we want to continue, then we will start from 2 again and we will use a while loop for continuous operation. Now entering into the programming part. First one is configuration of motor pins. Means PC0, PC1, PC2 and PC3. Like different exploration of programming, I have used the general terms. In every port, the data direction register and port registers are used. Here I am using port C of Atmega 328P. So I have used DDRC, port C and these 4 pins. I have used the general term. Similarly, for the case of enable, I have used PD5 and PD6. Here I am using the general term for programming. First thing, for motor pin configuration, PC0 to PC3, those 4 pins should be assigned as logic 1 to initialize as output. I have used port C here. So this first instruction has been used to assign D0, D1, D2 and D3 pin of DDRC as logic 1. This is used for assigning these 4 pins as output pin. The next instruction has been used to define D0, D1, D2 and D3 bits of port C as logic 0. So this is the initial value of port C to stop the motor at initial stage. Now we need to configure enable pin. Enable pins are connected at port D pin number 5 and port D pin number 6. So pin number D5 and pin number D6 of DDR-D register will be set as logic 1 both to identify D5 and D6 as output pin, and that is done by first instruction. Now to make it enable, the D5 and D6 pin of port D register should be set as logic 1. This is done by second instruction. So pin configuration for motors PC0 to PC3 and also for enable pin D5 and D6 has been configured or initialized. Next we need to write the program for movement of motors. For forward movement, what is the combination? PC0 is 0, PC1 is 1, PC2 is 1 and PC3 is 0. PC1 and PC2 will be in logic 1. That is done by setting D1 and D2 of port C with logic 1, and this has been done by this first instruction. Rest 2 bit D0 and D3 will be set as logic 0. This is done by using second instruction. So for forward movement, D0 to D3 of port C has been assigned like this combination. Now for backward movement, the combination will be just opposite. Means D1 and D2 pin of port C will be set as logic 0, and this has been done by using this instruction, and D0 and D3 will be set as logic 1, and that has been done by second instruction. So this is for backward movement. To stop robot, all these 4 pins will be reset as 0, 0, 0, 0. That is done by using these 2 instructions. So we may write the instruction using different combinations of these 4 pins as per the requirement, and we will follow this logic table. So we have written all the functions. Now in main function, we have to call the motor pin configuration function. Next we have to call the enable pin configuration function. And while loop, I have used different movement. First, say I want to move the robot in forward direction for 2 seconds. So this 2 second delay has been used. Next, say I want to stop the motor for 1 second. I want to move the robot in backward direction for 2 seconds. Again I want to stop, and this will continue. So these functions I have used in while loop. I may use the different functions like left direction, right direction, forward, backward, whatever might be. Now I am running the program. This is the diagram connection in Simul IDE, loading the hex code and running the program. What will happen? This 2 motor, first it will move in forward direction, means here 2 motor will move in same direction. Next it will stop. Next both motors will move in reverse direction. It will indicate the backward movement of the robot, and this will continue. See what is happening. Both in clockwise stop, both in anti-clockwise stop, both in clockwise and stop, both in anti-clockwise and stop. So the robot will move in forward and then stop and then backward direction. Throughout the discussion, I have discussed the basics behind the controlling of DC motor rotation, the explanation of hardwares, how to write C code for controlling the movement of DC motor, how to create hex file using Microchip Studio, how to load hex file into the microcontroller and run it in simulation. In next tutorial, I will describe more interfacing on AVR group of microcontrollers. Please subscribe, put your comments and queries in comment section.